prefix list. Prefix list can also be used to perform the route filtering. And this prefix list comes very handy when we need to match the prefixes in a certain range. Not only we need to match the prefixes in a range, but we also need to match the prefixes based on CIDR. Like if you need to match the prefixes based on CIDR, if we need to match the prefixes based on range and CIDR. Let's say, for example, we are given that if you need to, you need to block certain prefixes, you need to block the prefixes from this range, from 1.1.7.255, that you need to block the prefixes in this range, but only and only those prefixes you need to block that are coming on the CIDR /27 to /30. So if you need to block a set of prefixes, or if you need to permit a set of prefixes that are coming on a specific CIDR, a specific classless interdomain, a specific CIDR, a specific subnet mask, then this ACL concept is not going to work properly. Because in case of access control list, in case of ACL, actually, what you will need to do in case of access control list, you need to check your entire routing table. And in your routing table, you need to find out what prefixes are coming in this range, and they are in that particular subnet mask range. You need to match those prefixes one by one. In the access control list, you need to write down. In the ACL, you will need to write down the prefixes with the appropriate subnet mask, respectively. So you will create first of all, you will check your entire routing table. In your entire routing table, you will find out what prefixes are coming in the /28, /29, and /30, for example. And then you are going to either permit or deny the prefixes based on the same. So it can be done. It's not like we cannot do it with the help of the ACL. It can be done. Let's say, for example, in your entire routing table, let's say for your for example, in your entire routing table, there should not be any prefix with the subnet mask /28, /39, /30. That can be done with the help of the access list as well. You can do it with the help of the ACL, but the problem is that then in that case, you need to check the entire routing table. And in the entire routing table, you need to find out what prefixes are coming on /28 masks, what prefixes are coming on /29 masks, and what prefixes are coming on /30 masks. Once you have found that out, then you are going to use permit or deny statements in the ACL, and you are going to match them one by one, which might be suitable for a small network. But if you have thousands of prefixes in your routing table and you just want to filter some prefixes based on the mask, then using the ACL might not be a very good idea. We can use other techniques as well. We can use techniques such as prefix. So Prefix-List is used specifically in the case when we have to match the prefixes based on the CIDR. We can match the exact prefixes as well that we want to block, or we can match the prefixes. We can match a range of prefixes that is coming on a specific CIDR. Prefix-List allows us to match the prefixes based on a specific CIDR. Prefix-List allows us to match the prefixes based on a specific CIDR as well. And Prefix-List is very widely used in things such as route filtering, path manipulation. You will find that Prefix-List is very widely used in these situations. For example, when we talk about protocols such as BGP, Border Gateway Protocol, you will see that protocols such as BGP very extensively is going to use the Prefix-List to perform the best path manipulation, change in the path attributes, and also ACLs we can also use, but Prefix-List is also one way to do the same. So in Prefix-List, let's say, for example, we are given a range. Let's say in the Prefix-List, we are given a range that in the entire routing table, we have to block those prefixes that are coming on the CIDR /28, /29, and /30. And maybe in the entire routing table, we need to permit only those prefixes that are coming with the CIDR to the CIDR. So we can create a prefix list for the same. How can we create the prefix list for the same? We can use the keyword called IP prefix list, the name of the prefix list. We can also specify the sequence number of this statement, just like in ACL. The sequence number is incremented by 1. We can also specify it manually as well. Here also, we can specify the sequence number all by yourself. If you do not specify the sequence number of the statement, prefix list is automatically going to add a sequence number 5, then 10, then 15, then 555, it will increment the sequence number for the same. So if a prefix list has multiple statements, such as this prefix list has 3 statements, first statement will have the sequence number 5, second will have 10, third will have 15. So IP prefix list, name of the prefix list, then either permit or deny or whatever. Then here you need to write down the prefixes that you want to permit or deny. Remember that prefix list uses a concept of less than equal to, greater than equal to. Prefix list uses a concept of less than equal to, greater than equal to specify the CIDR range. this less than equal to, greater than equal to match the CIDR range. Like I want to block the prefixes from this CIDR to this CIDR, so that can be defined in the greater than equal to or less than equal to symbol. So greater than equal to, less than equal to, actually in prefix list is used to, in prefix list, the greater than equal to, less than equal to is used to actually match this greater than equal to, less than equal to is basically used to match the CIDR. So greater than equal to means if a prefix has a subnet mask greater than or equal to 28, then match it and deny it. Or if the prefix list, if the prefix has the subnet mask like less than or equal to 30, then match it and deny it. So this command greater than equal to, less than equal to, this command is going to match the range of the CIDR. Let's say, for example, 28 to 30. So greater than equal to 20, greater than equal to 20, and less than equal to 30. So it will automatically match like 28, 29, and 30 CIDR. So based on this greater than equal to, less than equal to, we are going to match the CIDR. We are going to match the prefixes. We are going to match the CIDR based on this greater than equal to or less than equal to. If we have specified just greater than equal to, if we have specified just greater than equal to, such as, for example, greater than equal to 28, that means it is going to match 28, 29, 30, 31, and 32. It is going to match all the CIDRs greater than equal to 28. And if we have specified such as like less than or equal to 30, it means it is going to match all the CIDRs less than or equal to 30. So 30, 29, 28, and then so on. So we can also specify these individually. Not necessarily we need to specify both of the thing. If you specify both of the thing, it is going to match a range of the CIDR. If you do not specify like both of the thing, maybe you have just specified the less than equal to, that means less than equal to CIDR 32, everything will match, or greater than equal to, just in case if you have specified only, that means greater than equal to that CIDR, it is just going to match. Now, if you do not specify anything, you have neither specified the greater than equal to or not the less than equal to, you have not specified like greater than equal to or less than equal to, like none of these. If you have not specified either greater than equal to or less than equal to, in that case, the prefix this is going to match this prefix as it is. It is not considered as a range. It is not a range. It becomes the range. Like I want to perform the filtering in this range. This becomes the range only and only when we have specified the greater than equal to, less than equal to, or maybe greater than equal to, less than equal to, both, all, only in that condition. If you have neither specified the greater than equal to, nor you have specified the less than equal to, in that situation, this is not a range. This is the exact subnet, exact route that you want to either deny or you want to filter. In this condition, for example, this statement, this is the default route. This is going to match the default, match one individual prefix. In this case, it is default route. If it was, let's say, for example, 10.0.0.0, it was 10.0.0.0/16. It was not a range. It was not a range. If it was like 10.00/16, it was not a range. It is not from 10.0.0.0 to 10.255.2. It is not that. It's 10.0.255.2. It is not a range. It is not. It is exact this prefix, like 10.0.0.0/16. Like if you have a route in your routing table, this one, it will be denied. It becomes range only when we specify like we want to perform the filtering from this range to this range. If you need to specify that you want to perform the filtering in this range on a specific CIDR, you need to mention that CIDR here in the format of greater than equal to, less than equal to, either both or individually, completely up to you. But until you specify this greater than equal to or less than equal to, this will not be treated as a range. So following the same concept here in this topology, we have a lot of prefixes. We have different prefixes. What I'm going to do now, I do have like these prefixes. We have these different prefixes. What I'm going to do now, I'm going to change the CIDR of these prefixes, 120. I'm going to change the CIDR of these prefixes, 130, to like some random numbers. So I will go to router number 12. I will go to router number 13. And on router number 12 and 13, I'm going to change the CIDR of the prefixes to something random. Right, so maybe I'm going to create a few more loopbacks as well. I'm going to basically loopback 1, loopback 2, loopback 5, and loopback 6. I'm going to configure loopback 6 with the IP address as well. And I'm also going to configure a loopback 7. right? So loopback 7 is going to be 7, is going to be 6. Okay, so yeah. This is 130.1.1.1. Okay, this is on like slash 24. Okay, so let me do it. 192, 25, 224, then 240, then 248, then 252, and 255. So I have changed the CIDRs. I have changed like the CIDRs of these prefixes here. So now the CIDR has become like some random numbers. So CIDR I have changed here. Same thing what I'm going to do, I'm going to change actually. Same thing what I'm going to do, I'm going to change the CIDR on that side as well, on the other side as well. So I'm going to change all these on here as well. Okay. So here it is changed, here it is changed. Also on router 9 also you have a few loopbacks you can check. Show IP interface brief. You have few loopbacks here as well. If you want, you can change the CIDRs here as well, completely up to you. But I'm going to let these come on the /32 mask itself. So show run interface loopback 0. It is on /32 mask. I will let it, advertise on /32 itself. So some prefixes now, if you check in the routing table anywhere, like let's say, for example, on router 3, you check the routes in the routing table, show IP route OSPF, you might see some prefixes here, some prefixes here, they are coming on /32, some are coming on /24, some are there on again /32, and then we have 130 subnets that are coming, that are being advertised on different, if I say 27, 26, 24, different masks. And then we also have 120 subnets that are also getting advertised on different masks. So in my routing table now, we have different prefixes. We have different prefixes with different masks. So in the routing table, we now have different prefixes with different masks. And what is asked for us, like we are asked that on router 3, we should not have any prefix in our routing table that has a CIDR of /24. We are asked that we should not have in the entire routing table. In the entire routing table, we should not have any prefix in the CIDR with the subnet mask value of 24. So we are asked that you need to create some sort of route filtering mechanism in such a way that your routing table does not have any prefix on the CIDR /24. So we'll go to router number 3, and on router number 3, I'm going to say configure terminal, IP prefix list, IP prefix list, the name of the prefix list. Then either you can specify the sequence number all by yourself. If you do not, it will choose the sequence number automatically. Then I'm going to say deny. What do you want to deny? Here now you have to represent the range. Here you have to represent the range in which you are going to perform the filtering. In what range you want to perform the filtering. Here you need to specify the IP address and subnet mask in such a way that it represents the range in which you want to perform the route filtering. So here you need to specify the range in the format of IP address and subnet mask. In the format of IP address and subnet mask, you need to specify the range in which you want to perform the route filtering. Since I want to perform the route filtering in the entire routing table, I am going to write down 0000/0. 0000/0 basically means that this is any IP, any mask, like the entire routing table. But if I hit enter right here, it is not going to consider it as a range. It is going to consider it as a default route. Because if I do not specify greater than equal to, or if I not specify the less than equal to, this will not be considered as a range in which we want to perform the filtering. Instead, it will be considered as a indivisible subnet that we might want to filter. So no, we cannot hit enter right here, because if we hit enter, the default route will be deleted from the routing table, and the rest of the routes might be permitted based on the statements that you will specify. But the point is, like IP prefix list, the name of the prefix list, then the deny, and right here we are actually saying that it is a range. It is not an indivisible prefix. We need to tell that it is a range. How can we do that? by specifying the greater than equal to and less than equal to after that. Now, we don't want any prefix on the CIDR/24. So what we need to write down? We need to write down that I do not, if I say greater than equal to 24, that means it is going to filter all the prefixes with the CIDR value of 24 and higher, 24, 25, 26, 27. So we don't want to do that. We want to limit it on single number, 24. So I'm also going to write down less than equal to 24. Greater than equal to 24, less than equal to 24 means 24. You cannot just specify EQ24 equal to 24. There is no such command. The command is only greater than equal to, command is only less than equal to. So what we should have done, we did greater than equal to 24, less than equal to 24, which means in a way 24. What is the number that is greater than equal to 24 and less than equal to 24? It is 24. So this is how we can match one CIDR. So now this will be treated as a range. Now the prefix list Cisco is going to block all the prefixes with the CIDR value of 24. The prefix list is going to block all the prefixes. The prefix list is going to block all the prefixes with the CIDR value of 24 in the entire routing table. In the entire routing table. In the entire routing table, all the prefixes with the CIDR value 24 will be blocked. And we also need to permit all the rest of the prefixes. So we just cannot say permit any. So what we need to say, IP prefix list Cisco permit again 0000 and less than equal to 32. This is permit any. This is any. Any means like IP mask, and then less than equal to. So this means that in entire routing table, all the other prefixes are permitted. So first statement, the IP prefix list Cisco, I'm going to deny in the entire routing table all the prefixes that have the CIDR value of 24. And in the second statement, I'm going to permit everything else, permit any. And then you can check it by the command show IP prefix list. You can see that I did not specify the sequence number. Sequence number got added automatically in 55. In ACL, it is in 1010, but in this prefix list, it is 55. And to apply this prefix list, same concept you have to use. You have to use the same distribute list concept, but you do not need to write down this like that. Because if you use the keyword distribute list and then the name and then in out or whatever, it will be considered as an ACL. So you need to write down distribute list prefix, and then you need to specify the prefix list, then the direction in or out. So in interface, out interface remains the same as the ACL that we discussed in the last class. This has no difference in terms of prefix list. The only change that you will see when it comes to applying that prefix list in the protocols such as OSPF is this keyword prefix. So this command says that I'm going to filter all the incoming prefixes with the help of the prefix list Cisco. That is what we mean by this command. Remember that we can also specify the interface, on which interface we want to filter. We can also specify out. We can specify out interface. All those things are discussed in the last class. You can refer to the recordings of the same. So that's it. This is how we create the prefix list, and this is how we apply the prefix list. So show IP route OSPF. If you check, you will not have any prefix in your routing table that is on the CIDR 24. You will not have any prefix in your routing table that has the CIDR of 24. You can see show IP route OSPF pipe include /24. So you don't have any 27. You do have the prefixes. 28, you do have the prefixes, but on 24, you don't have any prefix. So it is done. Create the prefix list, specify the permit or deny statement, and then use the router OSPF command, router EIGRP command, to router RIP command to filter the prefixes as per your requirement. So this is the range only when we specify the greater than equal to, less than equal to. If we did not specify greater than equal to, less than equal to, it is not a range. It will not be considered as a range. For example, now suddenly I remember that we don't need to block this. Suddenly I remember that we don't need to block this. Suddenly I remember that we don't need to block this. This has to be allowed. Suddenly I remember that this is allowed. This I want to allow actually. So show IP prefix list. I know in the prefix list, I know that if the things go to this statement, everything will be blocked. I know that if the things go to that particular statement, everything is going to be blocked. But I want to allow it. I want to allow those two certain prefixes. I want to allow those two certain prefixes. I want to allow this 200 subnet, 200.1.1.0 and 100.1.1.0. So if I write down the statement IP, prefix list, Cisco, permit 200.1.1.0/24, this is not a range. This is the indivisible prefix that you want to permit or block. But if you write down this command, the sequence number of this statement is going to be 15, which will go below this. And since everything is getting blocked at right this point on /24, it will never go to the next statement. So it doesn't make any sense that we apply this prefix list like that, IP prefix list and also. What we need to do after this, we need to specify the sequence number. Sequence number may be 3. I want this statement to be applied before this statement. Otherwise, as per the rules, when the router starts checking the prefix list access list, it will always follow the top to down approach, top to bottom approach. And if the statement, if the prefix matches a certain statement, if it is permitted, it will be allowed. If it is denied, it will be denied. No further inspection will be done on there. Same IP prefix list, Cisco sequence number of 4 maybe, and permit 100.1.1.0. This is not a range. This is indivisible prefix. It's not like we need to permit or deny certain prefixes in this range. It is this specific subnet. It is this specific subnet. Like this statement says, I am going to allow only this subnet and I'm going to allow only this subnet. No CIDR if you have specified after that, it is an indivisible prefix, not the subnet. And you can see do show IP route OSPF. You have that 100 subnet here only, and you have that 200 subnet here only. Rest the /24 prefixes are not there. So 100 subnet we have, 200 subnet we have. Show IP prefix list, you can use the statement to check. You can use this command to check what statements we have configured in the prefix list. So on router 3, basically, we are blocking the prefixes as per our requirement. We are blocking the prefixes as per our requirement. Fine. Show IP prefix list summary. Show IP prefix list detail. You can also see, like, how many number of prefixes, how many prefix lists you have configured and all, anytime the packet matches, hit count and everything, you can check it here as well. Now, this is a very basic use of the prefix list. This is where we did the filtering in the entire routing table. We don't need to do that. We did not want to do that. No IP prefix list Cisco. I want to do the route filtering, but I want to do the route filtering only in 120 and 130 range. I only need to perform the route filtering in 120 range and in 130 range. In the 120 range, I do not wish to receive any prefix on /26 to /28. And on /130 subnets, I don't wish to receive any subnets on /29 to /31. So again, one more thing to remember, if we have not configured the prefix list and we have just applied that prefix list in OSPF, it doesn't mean anything. Like you will still have all the routes. The prefix list has no impact in the routing table if you have not created it. There's no prefix list named Cisco now, but it is still applied in the router OSPF. It will have no impact on it. So anyway, IP, prefix list, Cisco, deny 120.1.0.0/21. What is the range in which we want to perform the filtering? The range is 120.1.0.0 to 120.1.7.255. This is the range in which we want to perform the filtering. So this IP address and the subnet mask, this IP address and subnet mask will give you that range of IP in which we want to perform the route filtering. This is the IP address and the subnet mask range. That in this range, actually, this is the range. The IP address and subnet mask we have mentioned, and this is the range in which we want to perform the route filtering. And then we need to specify. After that, we need to specify the greater than equal to 26 and less than equal to 28. Similar to that, IP prefix list, Cisco, deny 130.1.0.0/21, greater than equal to 29, less than equal to 31, and IP prefix list Cisco, permit 0000 less than equal to 32. So this is only going to be considered a range after we have specified either greater than equal to or less than equal to. Otherwise, the route, this router will deny exactly this route in the routing table, which actually is not available. So if you just enter this, it's not like it is going to block all the prefixes in this range. No, it is going to look up, the device is going to look up for this exact route, and then it is going to perform the filtering. Done. Check it. Do show IP route OSPF. So you have rest of the prefixes. But if you check do show IP route OSPF pipe include 120.1. In this 120.1, you do not have any prefix from the range 26, 25, 26, whatever it was. So you have blocked that. And if you check the 130 range, in the 130 range, you don't have the prefix 31 and 28 and whatever you blocked it. So in 120 range, we have blocked 26, 27, 28. So those are not there. And in the 130 range, we block 29, 30, 31. So that is not there. So this is how we can create the prefix list as per the requirement and block the certain prefixes in the routing table. We can block the range. We can block individual prefixes from installing in the routing table. This is how we can use the prefix list for route filtering based on prefix itself, based on CIDR given in the prefix. Range is this. Range will be given to you, like in what range you need to filter. They will tell you that, okay, this range you don't need to receive these prefixes. So range, they will tell you. You don't need to identify it. In the document that you have from your company, they will give you the range that you need to perform the filtering in this particular range. Here we have selected the range as 120.1. Here we have selected the range as 130.1. In your production environment, you will be given a range in which we want to perform when you want to perform the route filter. Now, other than this, we can also perform the route filtering. I think, like, why that cable is not there. So other than that, we can also use the prefix list for a different purpose as well. Not only this, we can use the prefix list for some different purposes as well. This is how we can perform the route filtering with the help of the prefix list in simple. But like, we can also use some other techniques for the same. No IP prefix list, Cisco, router OSPF, and I'm going to say like router OSPF and no command I'm going to use here. Let's go to maybe router number 12. Let's go to maybe router number 12. And here, let me do one thing. I'm receiving all the prefixes from EIGRP. As you can see, I can go to router number maybe 11, and there also I can see that I'm receiving all the prefixes from EIGRP. Now, I do not wish to receive any prefix from this gateway. I don't want to receive the prefixes from this gateway. I do not want to receive any prefix from this gateway. I want to receive the prefixes from this next hop only. I do not wish to receive the prefixes from this gateway. Yes.
So, sir, one query is that we are getting a prefix space of 123 for the class 16, right? But as per my company has suggested to block the prefix of 26 to 28 then. So, how can I identify the root from the class 21 then greater than less than we have configured? I mean, class 21, how can I identify class 21 prefixes to come under this?
You cannot. You cannot. You have to check, like you have to use like show IP route and then pipe include /21. So if you are saying that how what prefixes are coming on /21, you need to identify those. This is the way you need to identify this.
Basically, if the roots, what we will do in the roots, what we are receiving, class 16 we are receiving, if class 16 we are receiving, we have to do the filtering on the basis of class 16, then the range we will define. There is no less than what we have to define. But how the class 21 is coming, it is not understandable to me.
Class 21 is coming because like this we have already discussed here. Like in the last class, we discussed how to find out the range here. So like, yeah. If for example, if you are saying that how can we create that particular range? So it is based on the same thing. For example, we wanted to perform the filtering in this range. So I had to write down a network ID and subnet mask in such a way that actually, matches all the prefixes. So write down all the prefixes that you have to match, convert it into the binary, find out the network part, find out the host part, find out the network ID based on the same thing that we have done in the ACL in the last class. And just instead of using the wildcard mask, we need to find out the subnet mask. So you don't need to do a lot. Just check here, like, see how many bits are exactly the same. So 8-bit, and 1, 2, 3, 4, 5. So 5. So 8 plus 8 plus 5 is equal to again /21.
Okay. That's not from there it is.
Yeah. So whatever range is, like the range of prefixes that is given to you, convert all those ranges into binary and find out the network ID based on the same. And whatever part is common, find out the number of bits that are common. Find out the number of bits that are common in all those prefixes and put it like / and then whatever number of bits were common in all the prefixes. So for example, here total 21 bits are common in all the prefixes. So /21. Similar to that, for example, here, like total 22 bits are common. So 8 plus 8 plus 6. So /22. Okay. So we don't want to perform the filtering. We do not want to perform the filtering based on, let's say, prefixes. I want to perform the filtering based on this gateway. I want that I should not receive any prefix from that particular next hop. So from router EIGRP point of view, there are two gateways. If I go to router number FA 0 by 0, so this is FA 0 by 0, this is FA 0 by 1. Right, so this is FA 0 by 0 and this is FA 0 by 1. So I am receiving the prefixes from two like path, and I don't want to receive the prefixes from one of the gateway. Like this is my gateway, this is my gateway. I don't want to receive from one of them. I want that all the prefixes should be received from this gateway only, or maybe from this gateway only. I want to block all the prefixes from other gateways. I want that router number 12 should install the route in the routing table only from this gateway. It should not accept like any other routes from any other gateway. So we can also use the prefix list as a gateway filter list. So IP prefix list, same, maybe name Cisco. Then you need to permit. What gateway exactly? This gateway I want to permit. So write down this as like this. And IP prefix list, Cisco, deny everything else. So this prefix list that I have configured, the purpose of this prefix list is not to match the prefixes based on the IP address, but to match the prefixes based on the gateway. So I am receiving all the prefixes on router number 12. I am receiving all the prefixes on router number 12 from this and from this, and I do not want to receive the prefixes from anywhere other than this 100.1 subnet. So I have configured a prefix list called Cisco permit, and then here we have specified that gateway that I wish to receive the prefixes from, and here the rest of the things. And I'm going to say router EIGRP 100 and distribute list. This time I'm going to mention the keyword gateway. Distribute list gateway, and eventually we are going to use the prefix list anyway. So distribute list gateway, and then the name of the prefix list that we have configured, in, out, and all that. So if you have like multiple exit points, you can specify that I do not want to advertise the prefixes from this gateway, but from this gateway only. So in out direction, it can also be applied. Otherwise, you can just do it like that. So distribute list gateway keyword, not the prefix keyword. If you use the prefix keyword, it is going to filter the prefixes based on the IP address and mask. And if you use the gateway keyword, that means the prefix list will be used as the gateway filter list. This is what we refer to as the gateway filter list. So IP route EIGRP, you might see that all the prefixes you are now receiving only from one path, not from the other path. So looks like the gateway filter list is working perfectly. So from whatever gateway you want to allow the prefixes, match them in the prefix list, and rest block every other of them, and then you can just call it in the EIGRP OSPF. You can filter the prefixes based on the gateway as well. So we can use the prefix list as the gateway filter list as well. We can use the prefix list to perform the route filtering normally, and we can also use the prefix list as the gateway filter list. The prefix list can be used to filter the prefixes based on the gateway IP address as well. Also, we can mix both of them. We can mix both of them here. So then prefix list, match the prefixes, distribute list, prefix list, show IP prefix list. If you do not specify the greater than equal to, then exact matching will happen. If you have specified only greater than equal to, then greater than equal to. If you have specified only less than equal to, then less than equal to. And if you have specified both, then the certain range will be matched. Okay. So editing can be done as well by mentioning the sequence number as per the requirement. We can mention IP prefix list CCNP. We can mention the sequence number to add a statement before or after a particular statement. If you want to match a given range, then again, similar to that, we can match a given range as well. We needed to match this range. We found out that, okay, to match this range, the IP address and subnet mask will be this one. So we have written that down. Then greater than equal to, less than equal to, we have specified. So this is done. Here we can use the gateway one as well. IP prefix list, the name of the prefix list, then deny, then the gateway IP from where we want to filter, and then permit everything else, and then apply it in the page. We can use both at the same time, do it yourself. We can use both at the same time as well. For example, I want to permit these prefixes only from this gateway. I want to allow only these prefixes from this gateway. So create a prefix list that matches your prefixes and create a prefix list that matches your gateway and call both of them. Command is distribute list prefix that I want to filter these prefixes from this gateway only. Instead of using in out, we can use the keyword gateway in and out. So we can use both at the same time as well. We can use both at the same time as well. We can use like access list that filters the route and the access list that filters the gateway, both at the same time as well. IP prefix list, the name of the prefix list, then the range, and then greater than equal to, less than equal to, and then the IP prefix list, the name, and then permit that the gateway. And we have called both of them in the statement. So this statement says, I want to filter, I want to, as per this statement, I want to receive these prefixes only from this gateway. From everywhere else, block it. So we can use both at the same time. Prefix list can be used as the gateway filter list as well. Prefix list can be used to perform the route filtering based on the IP address subnet mask and range. Prefix list can also be used to perform the filtering based on the gateway. Yeah, these slides are available actually on the same portal. You can find that out from there. Now, prefix list can also be used. Prefix list can route filtering is not part of our CCIE content actually. That's why they are not there. Yeah, like what I can do, I will upload these in the portal only. Like it will not be there in the the hard copy that you have. It is not part of, so like these things, the like route filtering is not part of specifically the CCIE content. It is part of CCNP actually. So these slides specifically belong to the CCNP. But since we need to discuss the route map, like we are going to discuss the BGP, so you should aware of like these. So it's more like a revision thing that we are doing. I will upload these slides on the portal. You can have it from there for a reference. And you can also see that the topology is quite different here because this is topology from the CCNP, not from the CCIE. So this topic specifically belongs to the CCNP, not the CCIE. So that is why you might not have in the handout. But anyway, I will upload it. Now, the prefix list can also be used in specifically OSPF to filter the LSA. In OSPF, remember that we cannot filter the LSA. We did the route filtering on router 3, but as we have discussed in the last class as well, that route filtering techniques such as access list, such as prefix list, these route filtering techniques such as access list, prefix list, they are only and only going to filter the routes. And in OSPF, LSAs are exchanged. So we saw that in the last class that this router was not having the route, this router was not having the route, but these routers, they were having full routes in the routing table. Because when the router 3, when we perform the route filtering on router 3 and router 4, based on the access list, prefix list, the LSAs still get exchanged to the router number 5, to router number 6, to router number 1, to router number 2. And based on that, the information was getting there on 1 and 2 and 5 and 6. So I want to filter the LSA. If you want to filter the LSA, you have the options of that stub, totally stub, NSSA, totally NSSA. You can change the type of area. And by doing that, you can filter the LSAs. Second, we can use the distribute list. We can use the distribute list to filter the LSAs only on ASBR. Like if on router number 8, let's go on router number 8, and I want that this router show IP OSPF database, I want that this router should not advertise all of these type 7 LSAs. I do not want this router to advertise all these prefixes. I don't want that to happen. I want this router to only advertise 4, 5, 6, 7. I want that this router should not advertise these prefixes. I can use the access list, like access list 90 and deny 130.1.0.0, 0.0.3.255, access list 90, permit any, access list 90, permit any, then router, OSPF, distribute list 90 out. We can do that. Remember that distribute list in out direction does not work on OSPF because distribute list is going to filter the routes, and in OSPF, LSAs are exchanged. So distribute list does not work in the out direction in case of OSPF, except for ASBR. If we apply this distribute list in out direction on ASBR, it is in fact going to do show IP OSPF database. It is going to in fact filter. It is going to filter the LSAs. It is going to filter the LSAs. We do not have the LSAs now. Distribute list using the prefix list, using the access list to perform the route filtering, using the like access list and prefix list to perform the route filtering in out direction does not work in OSPF, because distribute list is going to filter, distribute list is going to advertise, it is going to filter only the routes, it does not take any action on the LSAs. But if we apply the same distribute list in ASVR, that distribute list is going to filter the LSAs. Otherwise, distribute list is not going to filter the link state advertisement. Distribute list can only filter the routes. Exception, ASVR. What we want to do here, we want to achieve the similar thing on ABR. This is how we can filter the type 5 or type 7 LSAs from being generated using the distribute list on the ASVR. We want to achieve the same kind of thing on the ABRs as well. I want that this router, which is, let's say, for example, router 1, I want the router that is router 9. I want these routers must not advertise that 9.9 subnet to the neighbor router. This is area border router, this is area border router, this is area border router, this is area border router. I can use a concept called area filter list. Area filter list in OSPF. There is a concept called area filter list in OSPF. The area filter list in OSPF can filter the LSAs. Area filter list in OSPF can filter the LSAs, specifically speaking, type 3 LSAs. Area filter list. Area filter list can be applied. Area filter list can be used in OSPF to filter the type 3 LSAs. Eventually, the area filter list is going to use the prefix list again. So nothing different. So prefix list. Area filter list in OSPF is going to filter the type 3 LSAs. And again, area filter list is going to use in backend. It is in fact going to use the prefix list for its working. So what I want to do, I want this router number 1. I want this router number 1 to advertise only 9.9 subnets to the neighbor router. I want this router number 2 to advertise only 9.9 subnet to the neighbor router. I want this router 1 and router 2 to advertise only 9.9 subnet to the neighbor router. How can I do that? I can go to router number 1. First of all, I'm going to create a prefix list. In that prefix list, I am going to match only these 9.9 subnets. I'm going to match only these 9.9 subnet. How can I do that? Configure terminal, IP prefix list, ABCD, whatever name you want to specify, then match 9.9.0.0 slash 22, sorry, slash 20 slash 30. So you want to match 0, 1, 2, 3. So the CIDR is going to be slash 30. So convert the bits into the binary and find out how many bits are exactly the same. You will find that 30 bits are exactly the same. So 9.9.0.0 slash 30 and less than equal to, since everything is on slash 32, so greater than equal to 32, less than equal to 32. So I have configured a prefix list called ABCD. There I have masked, permitted 9.9.0.0 slash 30 range. I have allowed the prefixes from this range that are coming on the CIDR slash 32, less than 32. So all these prefixes are on slash 32. So I have masked all that. Okay, and rest everything, of course, it's going to be denied. So you don't need to mention it, but other than that, everything is going to be denied. And then once you have configured the prefix list, use the keyword router OSPF and area. Command is area. Area, now understand this, area 3 filter list, ABCD, filter list, prefix, ABCD, and then again in or out. So currently on router number 1, we have 3 area. On router number 1, this is router 1, we have area 3, we have area 0, and we have area 1. If I write this command says area 3 filter list prefix out. What does it mean? It means that on router 1, when the prefixes are being advertised out of the area 3, then the filtering will take place. Area 3 out means when the router 1 is generating the type 3 LSAs of these prefixes and advertising it out of that area in area 1 and area 0, then we are going to perform that filtering. This command basically means, I do not want to advertise any other prefixes than these prefixes into both area 1 and area 0. This command basically means that from area 3, I am not going to advertise the prefixes to area 1 and area 2. Area 3 out means that from area 3, these prefixes are not going to be sent out in any other area. Area 3 out means like area 3 out direction. We have applied that prefix list. So those prefixes are not going to be available in either area 0 or area 1. So area 3, filter list and out. And make sure that you use the same commands on the second ABR as well, because otherwise the other ABR will keep advertising those prefixes. So I'm going to use the same command here as well on this area border router. So command is IP prefix list, name of the prefix list, then either permit or deny statement, whatever you wish to specify, and then router OSPF, then area 3, filter list, and then in and out. This command means that if a router has multiple area, such as router 1 has area 3, area 1 and area 0, the prefixes will not be sent out of the area 3. And you check, you go on router 3 maybe, and you check show IP route, OSPF, and you see that you have 9.9 subnets only. Where is that 11 subnet? Show IP route OSPF, pipe include 11, 11, 11, 11. You don't have that. Where is that 10.10.10 subnet, 9.9.9 subnet? You do not have any of those prefixes. Like of this area, from this area, only 9.9 subnets are allowed to go in area 0 and area 1. So I issued this command that says that on router number 2 and on router number 1, I use this command, prefix list, name of the prefix list, then what prefixes we want to permit, and then what prefixes we want to deny. And the area out means the prefixes when they are sent out of the area. When the prefixes are sent out of this area, the filtering will take place. Area 3, filter list, prefix out. But maybe we don't want to perform the filtering in this manner. Maybe I don't want to perform the filtering for both the area. I only want to perform the filtering in area 1. So I could have used the same keyword. I could have used the keyword instead of using this. I will remove this and I'm going to use the keyword area 1 filter list prefix ABCD in. It means that now when the prefixes enter in the area number 1, then the filtering will take place. Area 1 in means that the prefixes will be filtered specifically for area 1. They are not going to be filtered for the rest of the area. So I could have also used the filtering in this manner, where the filtering will take place, where the filtering will happen for one specific area, not for all the areas. So area 1 filter list prefix, and then the name, and then in we can use this statement as well. This command will only do the filtering on type 3 LSAs. That means rest all the things will be received as it is. Yes, so 120, 130, all the subnets will be there as it is. So now you check on router 3. You check on router 3. You see on router 3, we still don't have 9. We still don't have 11. But if you go on, let's say, for example, router 1, you can find out show IP OSPF database. You can see that in area 0, still all the prefixes are getting advertised. So the filtering did not take place in area 0. The filtering only took place in area number 1. So area filter list here, prefix list can also be used as the area filter list, because in OSPF distribute list will not work in the out direction as it is used to filter the routes, and OSPF exchanges the LSA. The exception is ASBR. So in OSPF, the devices, they exchange the LSAs, they execute the SPF, they calculate the route, and they install the route in the routing table. And right here, the distribute list is applied. But devices have already exchanged the LSA. To every device can individually execute the SPF respectively. So if you do the filtering on router number 2, router number 1 and router number 3, they will still have the route. So distribute list does not work in out direction in case of OSPF, exception ASPF. So we can use this thing called area filter list. This is our this area filter list can filter type 3 LSAs based on the prefix list again. It can only be applied on area border router because ABR is the only device that generates the type 3 LSA. So for example, there is a subnet 111 that I do not want to advertise only and only in area 0, but I want that subnet to get advertised in area 2. So what command I'm going to use? I'm going to use the command on ABR, area 0 filter list, whatever name, and in. That means when the prefixes enter the area 0, filtering will take place and the subnets are going to be blocked respectively. The filtering will not take place in this area because we did not use the command for that area. Similarly, we have a subnet called 12, which I don't wish to advertise either in this area or this area. So what I have used the command, I have used the command area 2 filter list out. That means when this area border router advertises the prefixes of this area out into the other area, first of all, it is going to apply the filtering. And as per the filtering, it is not even going to advertise these prefixes out either in this area or in this area. So direction here in the area filter list, is based on area itself, not based on the interface. Area filter, you can use this to filter type 3 LSAs applicable only on ABR. Prefix list again is going to be used for the same purpose. So use the prefix list, match your desired prefixes that you want to block and permit, and then apply it respectively onto the OSPF speaking router. So as you can see that prefix list has a lot of use cases. Prefix list has its use cases, but prefix list can be used to filter the route. Prefix list can be used to filter the LSAs. Prefix list can be used to filter the gateways. Like we have different use cases of the prefix list, but we do not still have here the option to match any two random IPs. We do not have the option to match even odd. We don't have those options actually. So it has its limitation as well. It has its advantages based on whichever, like, do you want to perform the filtering based on even number, odd number, two random IPs and all, you can go for the ACL. If you want to perform the filtering based on the CIDR, you can go for the area filter. You can go for the prefix. This is for this thing that we are talking about. This is for filtering. Again, this is for filtering. This is for filtering. This is not for like path manipulation. This is just for filtering. So the prefixes are going to be filtered. The prefixes are going to be filtered, and the prefixes that are basically getting filtered, they will not be available in the routing table. So if the other path goes down, you still will not see these prefixes in the routing table. So access list, standard, extended, prefix list, normal prefix list, we have to perform the filtering. Any doubts if you have, you can ask, let me know. All these options are available on all the protocols. All of these options are available in all of the protocols, REP, EIGRP, and OSPF as well. Any doubts so far, let me know. Okay.